In 2012, scientists in CERN laboratory made one of the most exciting scientific discoveries of the 21st century. They experimentally observed a fundamental particle called after physicist Peter Higgs, who with a group of scientists suggested the existence of the Higgs boson in 1964.
Throughout the history, people always been interested. What is the world made of? In 19th century, Dmitry Mendeleev introduced the periodic table of elements. Then, science discovered atoms. As it turned out, atoms consist of protons, electrons, and neutrons. And this is how we came to a standard model.
According to the standard model theory, everything in the universe, atoms, books, streets, planets and stars, all composed of infinitely small building bricks called fundamental particles. But before discovering the Higgs boson, there was a hole in this theory. Particles are the products of the field excitation, like this coffee.
I somehow disturb it, I produce Higgs bosons, and this works to any other fields and particles.
If there were no Higgs field, there wouldn't be anything in the universe. Now try to imagine that this paper is the whole universe, and this is the Higgs field. So now, the Higgs field is everywhere in the universe. Higgs field gives mass to particles.
For example, if I take these beads and drop them on a flat surface, they accelerate quickly and run away fast. But if I take the same beads and drop them into water, the water interacts with beads and slows down their acceleration.
This is what the Higgs field does.
Newton's second law of motion teaches us that mass is a measure of how difficult it is to accelerate body. That's why we can say the Higgs field gives mass to particles.
More interaction, bigger mass.
Quarks, for example, interact with Higgs field a lot. That's why they have larger mass and slower speed. But particles like photons are exception. They almost do not interact with Higgs field and also do not gain mass.
So that's why they can move at the speed of the light. But if all particles were able to move at the speed, they wouldn't be able to stick together and create matter. The Higgs boson became a final component that made a standard model a remarkable insight of how the strange quantum world works. But new breakthroughs emerge new questions. Maybe there is something even more fundamental. Thanks for watching.